So I know there are a few people here today who were not here for our opening session on Monday, so I just want to quickly reiterate what Aaron Hardick and Chris talked about when they opened the event and shared the reasoning behind our theme of Love Your Energy. So in the early 1900s, utilities were seen as these really important companies doing great work for the public, and were really admired. And then fast forward to the turn of the century, the perception was not quite so rosy. So now we're in this inflection point where we have utilities that are really thinking about what they want to be. So we have not only an opportunity to plan for the future, but to really create the future that we envision. We don't need to settle for just plain cheese pizza. We can have pineapple and jalapeno pizza if we want. So with that, please join me in welcoming our panelists. We have Arthur D'Andrea, Commissioner at the Texas PUC, Shuli Goodman, Founder and President of the Linux Foundation Energy, Jason Hanley, Director, Smart Grid Emerging Technology Operations at Duke Energy, and Julie Parsley, the CEO of Pedernales Electric Cooperative. So I'll just ask you each to quickly go down the line and sort of introduce yourselves and your organizations.
My name's Arthur D'Andrea. I work for the Texas Public Utility Commission. We regulate electricity and other things, but for the purpose of this talk, electricity here in Texas. And it's a very diverse and crazy marketplace. So there's all sorts of things going on. There's vertically integrated monopolies. There's a market in ERCOT. There are a bunch of cities and co-ops doing their own thing, and we have one here, and so that's what we do.
My name is Shuli Goodman, and I'm the Executive Director of LF Energy. And LF Energy is an ecosystem, the power systems that's part of the Linux Foundation. The Linux Foundation is the home of the Linux kernel, which is probably one of the greatest shared technology innovations that has ever occurred on the planet. And I often say that there were no armies and no politicians, and yet nearly every single part of your life, digital life, is actually touched by the Linux kernel. So LF Energy is in a home of ecosystems. 70% of mobile traffic is collaborating together at the Linux Foundation and LF networking. And 50% of all automobiles manufactured on the planet are collaborating together in automotive-grade Linux. And I just share a little bit of that background because when you see the panel, I'm probably the one that's kind of the most different because I'm not a utility and I'm not a regulator. But I am in the space and offering an ecosystem that is open for actually enabling technology innovation.
Good afternoon. I'm Jason Hanley. I'm with Duke Energy. I work in our Emerging Technology Office. I lead a group that does the research and development for Duke Energy. We are really looking kind of over the horizon for technologies that may be impacting Duke in the future. We're looking somewhere between 5 to 15 years out. The interesting thing about technology is technology keeps changing so fast, it's hard to put a number on it anymore. So we look at technologies and working with partners to bring those technologies in and look for opportunities that may be able to partner with, whether it be a university or a national lab, to bring new technology to the field.
Hello, my name is Julie Parsley, and I am CEO of Pedernales Electric Cooperative. It is not pronounced the way it's, like so many things in Texas, it's spelled differently than it's pronounced. Pedernales, not Pedernales. We are the largest distribution cooperative in the country. And we span kind of across central Texas. And we are different from an investor-owned utility because we are a cooperative and member-owned. And we can talk about that a little bit more later, but it's a great company. We've been innovative in our own way. A lot of cooperatives are very, very rural. Oh, there we are. This is us. And as you can see, we're in the middle of Texas. 8,100 square miles. Slightly smaller than the state of New Jersey, believe it or not. And you can see for the side that is our western side, we're very, very rural. We have 8,600 meters on that side. On the other side, we have closer to 312,000 meters. So we have a very diverse service territory, and so technology plays a big part in that role for us.
Thank you. So thinking about the future and loving your energy, what does that really mean to you? What is the ideal energy future that you envision? And Arthur, I'll start with you.
My vision for energy future is probably both expansive and very limited. My vision is that it be cheap, reliable, and clean. And that's really the end of it. There's nothing else to it, and that's for a good reason. And that's that regulators, and I think you may hear from others, regulators need to be careful not to pick favorites when technology is quickly changing. I don't want to be the guy who spends $10 billion of your tax money on the Betamax and makes everyone buy one. And because if you do that, not only do you run up costs, but you set modernization back. And so we are very careful as regulators to make sure that we don't pick and choose winners and losers, and that we don't get too excited about any technology, and that we don't favor the incumbents either, and that we create an environment where new technology can enter and enter into the market. And let me press on this a little bit further. I think there's an emerging scientific consensus, and I think it's fair to say emerging. Sometimes that's used as a negation operator, but I really think there is an emerging scientific consensus that although solar, wind, and batteries will be a huge part of our energy future, and maybe even the stars, solar, wind, and batteries alone aren't going to get us there yet. And so there remains some technology out there, and there's a bunch of candidates that is going to be that last big piece of the puzzle. And so as regulators, that's again something we have to be very careful about, is not to predetermine that and take us down the wrong path.
Well, I'm definitely with you around the cheap, clean, and green and reliable. I think that the part that I would talk about is the transition from a centralized to a centralized and distributed, kind of a heterogeneous environment, means that what we're going to have is a lot of resources at the edge. And so we're moving from really one-way flows of information. You guys all know this, but the part that I want to talk about is what happens when you actually shift to being a network of networks. And what is the pathway, the diffusion pathway around digitalization? My background is that I'm actually, my PhD is in innovation and the diffusion of innovation. And so I think a lot about, how do technologies get adopted? And at the Lennox Foundation, we never choose. What we do is we create transparent governance in an environment where end users and vendors, stakeholders can come together and really build what we would refer to as the plumbing of, the digital plumbing. And that's the way that the internet scaled. And that's the way that 5G is scaled. And that is the way that autonomous vehicles are going to scale. And that is the way that, blockchain has scaled. And so in each of these instances, in cloud, cloud is 12 or 13 years old since the first person kind of even used the word cloud. And it went from, nothing to ubiquitous. And the reason why it did that is because 100% of all the cloud providers work together at the Lennox Foundation on cloud native computing. So I give you that background because when I think of digitalization, we have to shift from 20% open source to 80% proprietary. We have to flip that because that's what other industries have done. And so what that means more is 80% open source and shared plumbing and 20% secret sauce. And what we need to be able to do is decouple hardware and software so that we can actually lower costs. And so that kind of disaggregation and virtualization has occurred in almost every other industry. And in many ways, we're laggards. And that's okay, because what it means is that we have a path forward in order to be able to accelerate the energy transition. And that includes being able to do plumbing and also really accelerate smart contracts and things like transactive energy. And the last thing I'll say is that one of the things that I hear folks talking about more than anything is that they want to create interoperability. But it's almost as if we believe that we're inventing this problem of interoperability, because interoperability has been solved in a lot of other industries, but it's been through shared innovation. It has not been through creating silos of proprietary software. So I think that, the Linux operating system ships with 10,000 drivers, and that's the reason why you have plug and play when it comes to networks. We have to do the same thing in energy so that we can really begin to, not only create at a centralized, but be able to create locally and consume locally energy and shift the paradigm dramatically.
Very good. I think my ideal energy future really revolves around an electrical grid that is able to facilitate a transactive energy future, where consumers and prosumers will be able to accomplish whatever energy transaction they want quickly, effectively, and with the lowest carbon footprint that they can have. The poles, wires, and cables that we have relied on traditionally and served us well from a one-way power flow systems also are going to need to be augmented. They're going to need to be augmented with more digital capabilities that's going to allow us to integrate more distributed energy resources, increasing the reliability and resiliency while maintaining cost and affordability. And this future is really going to be enabled by kind of a radical set of new system operations, distribution operations at utilities, while we're being governed by an evolving set of regulatory standards. Because really what we're trying to do is we're trying to move ourselves towards a convergence on the distribution side where ISOs and the distribution system and the customer load and assets can all interact with each other.
We have the same pressures in terms of cost, reliability, safety. Cybersecurity is very important in for the largeness and the rural nature of our footprint. So we have, because we are member-owned and because there is member participation in the decisions that we make, we are governed by an elected board. We have 7 directors. They are elected from different areas of our footprint. And so they bring with them their beliefs and their neighbors' beliefs about what our energy future should look like. So we're in a little bit of a different position because we are very responsive to our members. We have been offering new solar options for our members because they have asked for those things. We have a renewable rider. EVs have been more prominent. We have EV charging stations and a set a rate for that. So we are trying to be responsive to our membership because they own us. They are our shareholders. And so our energy future is, we can try to drive it ourselves, but we're really responsive to our membership and what they really want to see. And they are very concerned about cost and safety. So those are 2 things we focus on primarily.
Shuli, I know the Linux Foundation works globally, so what are some of the trends around digitalization and grid modernization that you're seeing around the world, and are those sort of translating back here in the US as well?
So from a little history or context, I've been really working on building this initiative for about the last 2.5 years. And for the last 18 months, RTE, the French transmission system operator, really has invested in building out the ecosystem. So a lot of my center of gravity has been, in the last 18 months, 20 months, has been in Europe. And so I can talk about that, although it is now shifting to Australia and Japan. And so I live in California, so I wake up, I'm on the phone from like 6 in the morning to 6 at night, which is tiring, but exciting. So in Europe, there is a very clear alignment between policies around decarbonization and digitization and kind of cooperation and collaboration. And I think that because of that, there really is this sense that even though you have these very clear nation states that, have a slightly different regulatory environments, there is a commitment, kind of as a European Union of the 42 TSOs and the, 1,800 or 2,300 DSOs, there is absolutely a commitment towards kind of shared investment. I think that, like in the United States, what's common is that there has not been the kind of investment in R&D. So like Duke is you're kind of a unicorn having the R&D that you have. RTE is another unicorn with a really big R&D. And so what that's enabled is really this notion of shared investment, because when I think about our energy future, we are the people responsible for decarbonization. If 94% of the carbon in the atmosphere that has to be removed to get to 100% is actually happening through either electrification or transportation, we are the people who are charged with doing that. And so that is driving it. And so this notion of net zero is very strong. In the United States, I think we have it at a state level. And so you have governors and states who've set those ambitions. But I believe that we can do it. And I think the hard part is that the more that we have at the edges of the future, where we're having climate collapses in the melting of the glaciers and the acidification of the ocean and the death of the barrier reefs, those are the future happening. And they are telling us this is happening and that we need to get out in front of that. And so we have a very short period of time to get 40% and then 100% decarbonization by 2050. And that, I think, is where Europe is absolutely going. Yet, atmosphere there's no national boundaries. It is global. And so we are going to have to deal with areas where there's rapid increase of use of fossil fuels. And so it becomes our problem as well. And I'd like to believe that as we begin to invest in that technology and that shared technology, that it can be diffused to other environments to help build resilient grids and resilient economies, which I think will also reduce the amount of mass migration.
And so Julie and Jason, we know that these trends will affect your business models and how you go about evaluating investments. So how do you, it'd be interesting to hear sort of the IOU perspective and then maybe the co-op perspective about how you go about evaluating and implementing new technologies.
Again, kind of what I was talking about it before, it is our members' money, and so we are very cautious about what we do. We're different from IOUs. IOUs, as you probably know, earn on and of their investments. We don't earn on our investments at all. We just recoup the actual money we spend from the membership. So we're in a slightly different place in terms of what we invest in and how we do. That being said, 20 years ago, we invested in a TWAC system, which is a very old system, but it's basically power line reading. Mm-hmm. So we have no meter readers. We have some ability to do remote disconnects and connects. It's been a great system. We're at end of life now, so we're trying to figure out the right way to manage it. So we are doing kind of a step. We're replacing all the meters that we're replacing with advanced metering. We're going to put the system out, but we're not going to do a big changeover because it's the most conservative way to go about doing it. I'm excited about getting it done, personally, because I think that that's going to help us in a lot of different ways with the ability to just manipulate our data, understand and have more flexibility. And I know that sounds kind of ancient that I'm excited about advanced metering for us, but it's going to make it will make a big difference for us as well.
Well, at Duke, we do have a pretty rigid technology approval process or evaluation process. It actually is called our funnel process. It's 5 steps. It's scan, monitor, assess, evaluate, and transfer. So the scan is kind of the big end of the funnel where we're looking at hundreds of different technologies. We're utilizing our partnerships with universities, national labs, the DOE, and maybe VC firms to help cull some of the technologies that may come down the funnel. From a scan perspective, from a monitor's perspective, we go into and look at building what we call a technology briefing sheet. So the technologies that make it down, it's a 1-page sheet that we can give over to our executives in case they get asked. And so we move into assess at the next level. We actually do a roadmap evaluation. So we're looking in more of the where's the technology going over the next 3 to 5 years. And we'll also at that point really look at doing a market map, a market study of the technology. As we move into evaluate, that's where we actually put hands-on products. That's where we actually do our testing. We bring it into our research labs. And to be able to do that, though, we actually have to have what we call a technology transfer partner out of the business. So someone from generation, someone from transmission or distribution or renewables that's going to be the owner of the product once, or the technology, once we get done evaluating the testing. So we believe that we go through this process pretty rigidly because with 7.4 million meters and 25 million customers, you can't afford to make a mistake on rolling out new technologies too soon. So even after we get done with the technology and transfer it to the business, we actually work with the business to do pre-scale deployments and serve as a subject matter experts.
And Arthur, as a regulator, how do you deal with that? Specifically renewables coming onto the grid or newer technologies. How does the PUC evaluate those technologies?
Yeah, so it's sort of, when you say technologies, there's sort of a large range, and I'll start with what Julie mentioned, which is the smart meter. So there's that category of smart meters, auto reclosers, things that seem boring at first but are actually terrifically exciting and make a huge difference in the lives of people and enable things like demand response and all sorts of things we dream of in the future. And those things, I'd probably like to backtrack a bit on my earlier comment. Those things we actually do cheat about. We implement policies. The legislature in particular will pass a statute that says go forward and spend billions of dollars on smart meters. And we allow the utilities to do that because these technologies, I'd almost say proven at this point. And that stuff's really exciting. And that we mostly just stand out of the way. Then there's stuff, I'd take a step up from there. We have something like, what are we gonna do with electric vehicles? What are we gonna do with batteries on the grid? And for stuff like that, we open something called the project, which is a place where stakeholders from around the industry can file comments, and we can meet in workshops and talk it out and make proposals. And we also work very closely, really shoulder to shoulder with ERCOT, who manages our grid, at least 90% of it, and to make sure that there won't be any reliability problems with this new technology, to make sure that ERCOT, which also runs the market, to make sure the market is not unreasonably favoring incumbents and will treat something like batteries the same. And then I would take it all the way up to, when you say technologies, you're talking about solar, wind, gas, modular nuke, all this new stuff coming on, and what do we do with that? And ERCOT watches that stuff closely for reliability. But again, I'd repeat there, we're kind of careful not to pick and choose because, and I know that may sound like a little, maybe even obnoxious, right? Like, how can you say this? We're talking about a threat to possible human civilization, and you're just sitting there saying you're ambivalent. Well, I'd say the proof is in the pudding because Texas leads the country in renewable deployment. And we have done that exactly with the market-based system that I'm describing. And it is my view that Texas will get there first and will get there cheapest.
Shuli, you kind of touched on this earlier, but you had mentioned on our prep call for this session that LF Energy is really like Switzerland and neutral, agnostic when it comes to technologies, and you really just provide a platform. So can you talk about how that really helps accelerate digitalization and how that might help Jason and Julie solve some of their problems?
So it may help to just explain a little bit like what the Linux Foundation is. Right now, about 150 million in revenue that comes from membership. 1,300 organizations are who are building businesses, and about 16 billion in shared value. The secret sauce is the governance. The secret sauce is the ability to create a neutral environment that separates business from technology and then really accelerates and enables. So what do those 200 people do to create that neutrality? It's training, which I think is incredibly important. I was looking at some of the numbers that in the next, by 2030, we probably have about 12 million people globally that work in energy and electricity, or in the electrification process. Let's talk about from a renewable standpoint. By 2030, it's going to be 24 million. So, and digitalization is going to be a really important part of that, because it's not only going to be about supply, it's also going to be about demand, and it's going to be about being able to create flexibility services and orchestrate. So moving from a control paradigm to an orchestration paradigm. So training is incredibly important to be able to, the process where a software becomes, you put out something in open source, and then you have to train people how to use it, and then you create compliance, and then through that you get certification, because we are talking about critical infrastructure. And so you want to, it's like, we can't just like say, here, have some software and build some electricity. It's way more complicated than that. So training's important, advances are important. We have some of the best IP lawyers in the world, and so a lot of it in the governance standpoint really has to do with how do you create a clear IP environment so that you can create shared innovation. And it's not just that these are little things. This is like the future that AT&T is betting on. This is the future. IBM has built their entire business on open source. Google has built their entire business on open source. So, we're not like making it up here. And that is what creates the neutrality, is to have an open environment. Anyone can participate. It's a duocracy in any of the technical projects. And, and I think that that's the secret sauce. And that's, I think, why the Linux operating system became so ubiquitous. And what's remarkable about it is that it's not only like at the supercomputer level or at the computer level or the enterprise level, but it's also down at the device level. So a lot of these things out at the edge that everybody's implementing, all of it is built on either, full stack Linux or small stack like, Zephyr or little RTOSes that enable for that kind of networking or those networks. So I think that that's what creates the neutrality, and it is, I think, one of the most, I came to them and I literally asked them, I need Switzerland, because I could see that this problem existed. And I could see that we needed someplace. And the response was, oh yeah, that's what people often ask for. So I think it's in the governance, and I think that it has worked and it will continue to work, and it's an opportunity for us to be able to really accelerate what we're doing and start wearing the white hats, as Steve Wesley was talking about.
Julie, we saw your slide earlier that showed how so much of your territory is in very rural areas. Some don't even have access to broadband. So how does that challenge affect your approach to modernization and digitalization?
That is one way, the reason that the TWAC system has been good, because it is over the power lines, and so that has been very helpful for us, even in our very rural areas. There's a movement afoot to help rural co-ops deploy broadband using their current infrastructure. In 1938, we were given $180 million, which is a whole lot for 1938, to electrify our service territory. And that, as a co-op, that again became the members' property. On that property, we would like to possibly run fiber and provide broadband to those who don't have it. We're engaged in a broadband feasibility study right now. My background, I am a lawyer, not an engineer, but is the fact that using the easements can be a difficult thing, because all the easements are electric. You start running telecom through those electric easements, and you can have a class action on your hands for misuse of easements. So there is a bill at the Texas legislature, which is meeting right now, to try to help with that. It's a kind of, for us, it's a fairly neutral bill. For some of the smaller co-ops, it will probably be helpful. But we are trying to figure out the best ways to deploy that broadband if it is feasible once we do our study. I think that would actually be a huge benefit for our rural areas. A smaller cooperative in Bandera, which is southwest of here, deployed broadband, and they actually saw an increase in their rural areas. I mean, we have people who want to live on ranches, and they want to live out in the country, and they want to do their work out there, and they can do it remotely if they have access to the broadband. So that's one of the things we really want to try to do, is provide that broadband access, and it would have the additional benefit of helping our system be more resilient as well.
Jason, are there any similar issues in your service territory?
Well, we're pretty much covered with broadband, so we're good. But I would like to get back to something that Shuli said a minute ago, because I think that one of the things that we've missed is the utilities is the use of open source. And so it's good that we are getting LF involved more, and we are going down this path, because for us, we've been doing open source work for the past 5 years, and that doesn't sound like a long time. But what we've come to find out is it is the way that we're going to have to operate in the future. We've committed to things called Open Field Message Bus, where we're doing a lot of the aggregation of communications out at the edge. We're doing distributed intelligence at the edge, to where we can solve problems locally much faster and share data between disparate devices. So reclosers can talk to meters, can talk to relays. If you're on the whitelist. So it's all security-based with security encryption keys. But we're also now embarking on something called the Open Distributed System Platform. It's an industry-led coalition that we're a part of, and we're really looking at this as a way to build on top of this open field message bus from a non-proprietary side. And OpenDSP is interesting to us because it's more than just a standard, it's actual code. Just like Linux, it's available to anyone that's going to want it. And that code is really there to allow for really good level control of the grid. So we think that the open source system is probably the wave of the future for us.
And what role do y'all see public-private partnerships playing when it comes to grid modernization, Arthur?
It's funny, in some ways we've gotten in Texas away from public-private partnerships. The standard utility regulation model for hundreds of years, going back to when the king first gave someone a license to set up a dock or a wharf, and the private citizen then built the dock or the wharf and was given a license by the king and earned a rate of return, and that's what we've done for a long time. And we just got away from that in the last 10 to 20 years, where we have some that are private transmission lines. All the wires are done in sort of the traditional public-private partnership. We let a private entity invest capital, we guarantee them a rate of return. But other than that, we have a lot of private entities generating electricity. We have private entities selling the electricity, or we have cities and co-ops, which are fully public, although I guess if you could call a PPA something of a private-public partnership. In some ways we've gotten away from it, though I see a lot of potential for things like cybersecurity. It's definitely, and for a lot of the reasons that I think one of the themes of this is sort of the benefits of decentralized decision-making and development. And you've heard a lot of that from Shuli. Cybersecurity, inherent decentralized systems are a lot safer. It doesn't strike me as a terribly good idea for government to take over all of that cybersecurity, because then you could just hack into the PUC and you're done, and you've got access to the entire Texas grid. And government has not shown itself very capable of keeping people out of its systems. And on the other hand, I don't think it's something the government's not entirely comfortable vesting all of that authority in private entities to just say, trust us, we've got this, the grid is safe in our hands. And so I think there's a lot of opportunity for public and private to work together. The government can help coordinate responses and serve as a clearinghouse for sort of best practices and help the little guys out who may not have access to what some of the big utilities do, while still leaving a lot of the cybersecurity work in private hands where it can be distributed. Because that's one of the real benefits, I think, of the Texas grid, and a lot of places look like this, is there's a real diverse regulatory environment. There are, as I said, there's 90% of Texas is this market where the invisible hand makes these sort of decisions. And then we have investor-owned utilities on the margins of Texas, which is the old-fashioned model. They're private entities, but they do everything. And then we have our little pockets of socialism, which work quite nicely. That's, our cities and our co-ops. And these are just, the people own the means of production. And it works quite nicely. And all that sort of diversity it creates a bunch of different decision makers and a bunch of different models and a bunch of different security software. And all of those things work really well because if one person fails, we catch the failure right away and we all move in a different direction. And we haven't committed the entire state down some pathway that we realize 10 years later is a mistake.
Any follow-up comments, Jason?
I think that public-private partnerships are going to be essential for us as we move forward if we really want to achieve a transformation in the electrical grid. The idea that of sharing risk and costs is very attractive to a utility. And we have seen this already in a couple of aspects. I mean, we have had some good learnings through projects with NIST and the DOE on the smart grid interoperability framework, as well as what's going on right now with the DSPX future grid projects. And what's also been shaping us a little bit more closer to home with locally based Charlotte Jules Accelerator, that we're taking in new entrepreneurs and new companies that are providing startups and technology to us that are going to help make the grid more flexible, reliable, and secure.
And so there's this famous saying that, history repeats itself. So what are some lessons learned in the past that things we've done that may have stifled transformation in the past that we would not want to repeat in the future? I mean, I'll start with Julie and kind of work our way back this way.
Well, I think overregulation. I was a regulator in a past life, so I can say that. But I do think some markets have been overregulated, and I do think that free markets and open markets work better. I think that will make a big difference. I take a little umbrage with being social. We are democratic. We are elected. We have an elected board. But we are a vertically integrated utility inside of ERCOT, which is unusual. It's usually just us and the municipally owned utilities, the co-ops and municipally owned utilities. But I really think that having forward-looking open markets is really a good way to move forward, in my opinion.
So there's another old saying. It says, I have met the enemy and he is us. Utilities do it to ourselves. And it is this proprietary nature of the technologies that we have insisted on over the past 30, 40 years. It is to where we individually, not as an industry group, but individually as companies go out and procure systems that have specific recommendations only applicable for your company. And we're stifling our ability to innovate because we have to go back to the same company over and over again for the life of that to make any changes at all. We can't adapt quickly. We can't be modern. We can't be flexible in the way that we go out and implement systems. So I think for us, we've got to come to the fact that we've got to flip it on its end and go 80% open source, 20% proprietary.
I agree with both of you. I'm way there for the free markets. Obviously, because it is a public benefit, I think that there are unintended consequences that could occur through this transition, and that that's your job, is to really create a forum for us as a society to be able to really manage and watch that. And so, I think of it as a Gordian knot, and for me, it is an incredible privilege to be doing the work that I'm doing. And I was at SIGRE in August, and I walked away from that, which is kind of one of the largest gathering of power systems people on the planet. And I was really sad, because I thought to myself, this is a Gordian knot. We've got regulators, incumbent vendors, and utilities. And if you start to pull on one of it, it just makes it all get tighter. And we have to come up with something that's going to kind of, the way that the Gordian knot got solved was Alexander the Great went up and just cut it. We have to figure out how to defy the logic of the past and really create the environment for the future that is going to allow us to transform. And if we continue to believe that, we're going to be doing the same things. 90% of what we do in the next 10 years is going to be the same as what we did for the last 100 years. We're like, not only are the utilities doomed, but the planet's doomed. However, I also think that commercial and industrial will just take over. Because the moment that they basically say, you know what, this isn't working for us, and we actually want a more flexible system, when a company like Target says that, their second largest expense is energy, what is going to stop them from just flipping the whole paradigm on its end? And that will accelerate. So I hope we can break the Gordian knot.
So what mistakes have we made in the past that have stifled transformation? I think I'd like to answer that first kind of generally, and then I'll give a specific example. And generally, I want to go back to what I started with, and that's that too often we've treated technologies as football teams, right? Where it's I'm on team wind or I'm on team carbon capture, and that has created problems. And so I think I'd like to challenge you, if you're conservative out there, take off your blue jersey and put on your engineering or your economist hat when you're evaluating solar and wind and batteries. And likewise, if you're progressive, I'd like to challenge you to take off your blue team jersey and put on your economist or your engineering hat when you're looking at things like modular nuclear reactors or carbon capture, because any of these things might be would end up solving and modernizing our grid. And now let me move to a more controversial specific example. And I think, if the more serious projections of climate change come to pass, the answer to this question is blindingly obvious. And that is, in 1990, we could have all been France. We could have had a 100% decarbonized grid. And yet, we chose teams. We chose teams back in the 70s, and nuke was killed because it was unpopular. And now granted, it creates all sort of externalities, I'll grant you that. But, if you accept the more serious projections of climate change, which is the complete annihilation of the human race, well then, wouldn't it be preferable to have maybe some low-grade uranium buried somewhere in West Texas? So, I don't mean, which is really sad because a lot of people have dedicated, their entire careers to protecting the planet, and it may just turn out that they've done more harm than good. And so, think of that as a cautionary tale as we go forward. And I'm not trying to single out any side here because both sides have done this, right? This is a cautionary tale. Keep your heart open and don't play politics with this stuff.
So I think we've got time for maybe one question, if anybody has a question out there. Oh, right here.
As you guys look to the future, what makes you most optimistic about the future of the energy system? So we ended with sort of a dire note of the end of the world as we know it. As you think about the energy future, what are the things that you're seeing that are most positive indicators about the energy of the future?
Go ahead, please. I think it's incredibly, I'll be quick. It's, there's so much innovation. The people that work in this country and others are innovators, they're driven. I have no doubt that they will find solutions to all the problems that face us.
In 1998, when I started building, or 1997, the first database queries with Netscape 2, we had this notion of convergence where we were going to have, the internet was going to take over media and television, and it was like everything. And we talked about convergence, and we had no idea how we were going to do it. But 20 years later, not only have we done it, but we have revolutionized our society even, more than we possibly can imagine in terms of connecting the planet. And so I actually really believe that it's an unbelievable example that in 20 years, we can get this. We can do this. And it is going to require a kind of cooperation that we haven't done yet, but I think we can do it, and that's what I look forward to.
For me, I think it's the fact that a 140-year-old investor-owned, vertically integrated Southern utility has just opened a digital transformation building with 400 data scientists, application developers, and designers with embedded business professionals from HR, finance, generation, everywhere, and they're solving problems of tomorrow. It's a different attitude and atmosphere than we've had at a traditional old utility, and I think that's what I walk away with.
For us, I really think it's something as simple as batteries. I mean, just to bring it right down to a real base, we hopefully have a battery project. We also have extensive solar on our system, as you can see. It's the western part of Texas. There's a lot of opportunities for solar. We have some community solar. But I think battery storage, because we have so much intermittent power in Texas. It's the home of intermittent power. I mean, wind and sun, I mean, it's everywhere. So honestly, for me, for our market, and once we can actually store it and figure out responsibly how to store it, how to then put it back on the system, how that works as a market, as well as a functionality, I think I really believe that's gonna really transform the market for us.
Well, we'll end on that positive note. Please join me in thanking our panelists today, and we'll see you around.